So we have completed till now stoichiometric defects. So the stoichiometric defect is nothing but already we have deal with that topic. I mean, stoichiometry means the solid maintains its stoichiometry throughout its reaction, right? So if it undergo into some changes also, then also what happens here in the solid, it maintains its stoichiometric ratio, right? So that means the number of positives are equal to the number of negatives. I mean, if I take three positively charged species, then the negatives are equal. That means the ratio is equal, right? So throughout, we cannot say directly that the positive and negative are equal, but they are equal in ratio, right? So those type of stoichiometric defects are, defects are called as stoichiometric defects. And then later we have discussed the two type of stoichiometric defects, and those are very important parts, right? One is Frankel, and other one is what I can say is Schottky defect. In Schottky defect, don't forget the density decreases, but in case of Frankel defect, definitely density remains the same. And coming to the definitions, if the equal number of positive and negative ions are missing in a crystal, then those type of defects are called as Schottky defect. If and in case of Frankel defect, here there will be no missing, but in actual what happens is the small ions like cation, they misses their actual position, and they come to somewhere in the crystal itself, that is nothing but the interstitial space or interstitial side, we can say, right? So these two type we saw, but in today's class we will see non-stoichiometric defects. So these are also very important. The name itself indicates that non-stoichiometry. That means here ratio will not be maintained throughout the reaction, or while it undergo into the defect. I mean solid, right? So here non-stoichiometric defect is nothing but in some cases what happens, more positively charged species may present, and in some cases the positive charge, I mean here in this case directly we will go, I mean there are two types: metal excess defect and metal deficiency. So before moving to this, I just want to remind you that metals are nothing but the positively charged species here. We directly, when we can say in the physical chemistry that the metal is nothing but a positively charged species, right? In case of organic, we cannot say that the positive charged species are metals, right? Why? Because in most of the cases, we get positive charge on the carbon, so carbon is not a metal. So that's why in physical chemistry, what we can say is metal is nothing but the positively charged carrying species, right? And that positive charge will come how? Whenever there is a loss, right? These are the very basic things we already learned in our first year, right? So now metal excess is nothing but here the positive charge are more, right? The name itself indicates here, what we going to see is there are more number of metal, and how this defect will arises we will see later. And here see in the name itself, one we can decide here metal deficiency is nothing but less, right? Here I mean directly or indirectly, one we can say here, in some case metals are more, right? That means positive is dominating at way at the metal excess defect, and in metal deficiency the positive are less, I mean negative charges are dominating, right? So different cases we will see, or we come across now, right? So in non-stoichiometric defect, that means non-stoichiometry is nothing but, I mean definition if you want, then already I have given. Then also you can see that the non-stoichiometric is nothing but here the I mean ratio is not maintaining throughout the reaction or while it undergo into the defect, right? So that type of defect is nothing but non-stoichiometric defect. It is dead opposite of what stoichiometric defect. So here, non-stoichiometric defect can also be further classified into metal excess and metal deficiency type of defect. First, we will see what is metal excess defect and how it arises. Right? What are the causes? I mean, sometime in the year of 2017, this question has been asked: what are metal excess defect and write its give its any two causes, right? So we will see metal excess defect. So here in metal excess defect, directly one we can say that the positive charges are more, right? Positively charged species are more, one we can say. So here this this type of defect arises due to two reasons, very important. One is due to anionic vacancy, due to anionic vacancy. This is the first cause, or this is the first reason why this excess defect, I mean metal excess defect, arises in any solids. Sometimes what happens when we expose these solids, I mean solid chemicals into the physical changes, heat or sunlight, or we bring this solid into the contact of other chemicals, then what happens? There may be an oxidation takes place due to the environmental changes. There may be reduction takes place, right? That means any chemical, if we expose, then definitely there what happens? The changes will come. Like one we can say the new book, I mean textbook, or else your reader. What happens when it is new? The pages are very white and bright, right? But like time, how the time passes, then definitely the color, color dimness will come into the color. Why? Because of some chemical changes. Like that, if we expose any solid into the sunlight or physical changes, then definitely some of the anion means here negative charge species. Some of the anion may miss, right? Some of the anion may miss. Say for example, positive, negative, negative, positive, like this, positive or negative. If this is the case before, I mean when it is very new, as time passes, it undergo into some changes. Like what may be the changes is nothing but the negative charge may miss from it, right? Positive, negative, positive, positive, negative. That means see here this type of here now when we can come directly to the metal excess defect. So here see the number of positive are equal to the number of negative. I can say directly, right? So clearly we can see here, right? There are 3 positive and 3 negative. But when it undergo into some physical changes, then definitely, or chemical changes when we can say, definitely if the negative part is missing, right? If the negative part, now there are 3 positive, but 3 positive are not equal to 2 negative. I mean 2 negative, right? The 3 positive not equal to 2 negative. That means here which charge is dominating, or else which charge is more here? Positive charge. And what for due to that reason, what if any solid undergo into such changes with keeping more positive charge in it, then definitely this type of defect will arise. So very simple, due to anionic vacancy. An ion is vacant now. I mean empty one we can say. So that is the reason why one we can say this excess defect will arises. I mean metal excess defect arises very clearly one we can solve. This is the first reason, and the second and very most important reason is, right, one more reason is nothing but, see, due to the presence of extra cation, right? Second one is, these two are very important due to the extra presence of extra cation. So no need to explain this, right? So directly one we can understand, due to the presence of extra cation. Say for example, if 2Fe plus 2, see, iron, now you can understand very easily, iron can form, I mean, plus 5 oxidation state also sometime. So that means the most preferable oxidation state for this iron is plus 2, plus 3. And now see, due to extra, I mean, before it was 2 and now there are 3. That means here, due to extra cation, one cation is extra now, right? Before there were 2 only, but now after going some changes in it, one extra charge will come. Or else, if you understand like this also, then also it is very easy. Now you can very easily understand. See, one extra positive charge has came. That means presence of extra cation. There were 2 only before. Now again, because of some changes, one extra cation came. So that means this type of changes again takes place or took place in any solids. Then definitely the metal excess defect will come in that particular solid. So this is what about metal excess defect. I have given the notes in detail, so please go through it. Right? I have reminded you, these are very easy concepts. So when you can read these concepts, then definitely very easily you can understand these things. And next is metal deficiency. Metal deficiency defect. So deficiency means what? Less. I mean, metals are less here, right? So here this metal deficiency defect has not any have any causes. So directly one we can say, whenever a metal undergoes into some defect, then if, see, 3Fe plus 2 undergo into the reaction to give 2Fe plus 2 or plus 3 one we can say. So this is the case how what we can say is, before there were 3 iron with plus 2 charge. After defect, what happened? The number of iron decreased. That means less metal. Iron is a metal. There were 3 metals before. After undergoing into the some changes or defect, then what happened? The number of iron became 2, right? So that's why this metal deficiency defect arises due to decrease in the number of what? Positively charged species. I mean, iron has decreased, right? So directly one we can show here with the diagram. That means it will be very easy for you, right? Fe plus 2, O minus 2, O minus 2, Fe plus 2, Fe plus 2 again, O minus 2. So now see here, there are 6 negative charge with 6 positive charge. So that's why before going into the defect, the case was like this with this solid. And later what happens is, metal decreases. I mean, one metal will go, right, Fe plus 3 plus 3 now. O minus 2. O minus 2. Fe plus 3. Sorry. O minus 2 again. See here. Charges are same. Very important. See this diagram. Very easy this is. Now you can easily understand. So now see. Charges are equal. But what happened? Because of plus 3 charge, plus 3 plus 3, 6, plus 6 and minus 6. And now what happened? One metal is what escaped, right? That means metal deficiency came here. There were 3 metals, but now because of one extra loss in the charge, what happened? They restricted to 2 only. So such defects are called as what? Metal deficiency defect. So this is all about today's class, right? So in the tomorrow's class, we will see next further part of it.